Hey guys, so for the past couple of days, we've been talking about imaginary numbers. And then last week sometime, we were talking about writing equations given the zeros. So that was like if you were given the zeros like 1 and 2, then you would write out the factors x minus 1 and x minus 2, and you would multiply them together. So now we're looking at something where we have imaginary zeros and we want to write out the equation given these imaginary zeros. So we're going to start with a kind of simple one, and we have the zeros plus or minus 3i. So just a note to kind of keep in your mind, anytime that you have an I as one of your roots, you're going to have the positive version and the negative version of that root because it came from a square root. So if you have positive 3i, you're also going to have negative 3i. That's going to apply to any number that has an I in it. If you have positive 7i, you're going to have negative 7i. If you have negative 43i, you're going to have positive 43i. So just make a mental note that if you have the negative version, you're going to have the positive version of the I. So then with that being said, our two roots in this are positive 3i and negative 3i. So we're going to write out our factors just like normal. So we're going to have x minus our first zero, so x minus 3i, and then x minus negative 3i is going to be x plus 3i. So now we're just going to multiply these together. So x times x is x squared. X times 3i looks weird, but it's going to be plus 3ix. Negative 3i times x is going to be minus 3ix. And negative 3i times positive 3i is going to be negative 3 times positive 3 is negative 9. And I times I is I squared. So now we just need to simplify this. So the first thing to note is that you have positive 3ix and negative 3ix. So those two are going to cancel out, and you're going to have x squared minus 9i squared. So then if you remember from our imaginary numbers video, I squared is going to be equal to negative 1. So we can replace this I squared with negative 1. So we're going to have x squared minus 9 times negative 1. And if we simplify that all the way out, we're going to end up with x squared minus 9 times negative 1 is going to give us plus 9. So if you're given the roots plus or minus 3i, that's going to come from the equation y equals x squared plus 9. So then I want you guys to pause and try to do that with plus or minus 5i, and just unpause when you're ready to see me go over it. So we're going to write the factors first. So we have positive 5i and negative 5i. So we're going to have x minus the positive 5i and x minus the negative 5i, which is just going to be x plus 5i. So then we're going to multiply everything out. So x times x is x squared. X times 5i is plus 5ix. Negative 5i times x is minus 5ix. And negative 5i times positive 5i is negative 25i squared. So then the positive 5ix and the negative 5ix are going to cancel. And you'll have x squared minus 25i squared. The I squared is going to be changed to negative 1. So x squared minus 25 times negative 1. And then that's going to become y equals x squared plus 25. And then you can really the whole time have the y equals in here and just like carry it down. I sometimes just add it at the very end because I know that my equation is going to be like y equals something. But basically you're going to get x squared plus 25. So then where it gets to be a little bit more complicated is because you don't always have simple roots like plus or minus 3i and plus or minus 5i. Most of the time, there's going to be a number in front of whatever your imaginary is. So in this case, we have 1 plus or minus 2i. So that means our two roots are 1 plus 2i and 1 minus 2i. So that already is a little bit different. So you guys don't have to write this slide down, but I want you to see me go through it. And then I'm going to show you how to do it in a quicker way. So our two factors from this is going to be x minus 1 plus 2i and x minus 1 minus 2i. So the first thing I'm going to do so that I don't have two sets of parentheses for each of these factors is distribute these negatives into my factors. So for my first term or my first factor, I'll have x minus 1 minus 2i. For my second one, I'll have x minus 1, and then my negative distributed to negative 2i is going to give me plus 2i. So now I have two trinomials that I have to multiply together. So this is going to take a little bit more work than the two binomials that we had in previous problems. So I'm still starting with x times x, and I'll get x squared. And then I'll do x times minus 1 and get minus x, and x times 2i and get plus 2ix. So now my x has been multiplied by everything, and I need to multiply negative 1 by everything in the second factor. So negative 1 times x is going to give me negative x. Negative 1 times negative 1 actually gives me positive 1. And negative 1 times 2i is going to give me a negative 2ix. And then the last thing I need to do is multiply my negative 2i times everything. So I'm going to have negative 2i times x is negative 2ix, negative 2i. I think I made a mistake on the last one. It was supposed to be negative 1 times 2i, not times 2ix. So I accidentally put an extra x in there right here. So that was for my negative 1 here that was being multiplied by 2i to get this term was supposed to be just plain negative 2i. So then moving forward to my negative 2i times x, I have negative 2ix. Negative 2i times negative 1 is going to be plus 2i. And negative 2i times positive 2i is going to be negative 4i squared. So now I have to combine all of the like terms for this. So I have, for one, I have my negative 2i here, and then I have a positive 2i. So those two are going to cancel out. I also have a positive 2ix and a negative 2ix. So those two are going to cancel out. And then I'm left with x squared minus x plus 1 minus 4i squared. And then again, just like before, we're going to replace I squared with just a negative 1. So, okay, sorry, I pressed a button somewhere. So the negative 4 is going to be multiplied by negative 1 instead of I squared. And so then I'm going to simplify that out again, and I would have x squared minus x plus 1. Negative 4 times negative 1 is going to be plus 4. And I can combine my two constants, so I would have x squared minus x plus 5 as, well, minus x combined with minus x, so that was supposed to be minus 2x. I forgot this minus x, so that's another minus 2x there. So it would be x squared minus 2x plus 5. So again, that's the long way of doing it, and as you saw, I got confused a couple of times in that just because there's so many numbers to try to put together. So then what you can do is you can use this shortcut. So before you try to understand the shortcut, just write the shortcut down. And so you might want to pause it and write it down, and then unpause when you're ready to hear me talking about it. So basically, anytime that you have a number plus or minus an I, you're going to be able to use this term. So the A is going to be the number that you're adding to the imaginary, and the b term is going to be the number that is physically being multiplied by the I. So instead of having to go through this whole process, what you can do instead is just follow this. And so the first term in your equation that you're writing is always going to be x squared. And then your second term is always going to be minus 2x times this a value. And your third term is going to be the two imaginary roots being multiplied together. And you can actually do this in your calculator if you have a TI-84, and I'll show you how to do that. And then you can also just do it in Google. So I'll show you how to do that as well. So we're going to try that with this equation that we just did all of that work for. So I'm going to do it using the shortcut. So my first term is always x squared. Then I have minus 2x times my a value, which is 1. And then I'm going to have plus a plus bi, which is going to be 1 plus 2i. And a minus bi is going to be 1 minus 2i. So I'm going to put those in here. 1 plus 2i and 1 minus 2i. And so then I'm just going to simplify from there. So I'm going to have x squared minus 2x and then plus this number. So like I said, you can find that in your calculator. So if you're on a TI-84, the first thing that you want to do so that you can actually get imaginary numbers in here is you're going to want to go to mode. And probably when you scroll down, your calculator is currently on real mode. If you go over 1, you can see a plus bi. And you're going to want to select that mode by pressing enter and then hit second mode. And now that enables your calculator to be able to read what I is. And what we want to type in is 1 plus 2i and 1 minus 2i. So I'm going to put my parentheses and do 1 plus 2. To get the I in there, I'm going to hit second decimal point. And then I'm going to do 1 minus 2i. And whenever you type all of that in, it just gives you 5. So then you can come back here and write plus 5. And that's your answer. And that's the same answer we got when I worked it out by hand, and it took a long time and I made a couple of mistakes. So you can just use the shortcut to get the same answer. So what I want you to do is to try to do that for these two. So like pause the video, try to use the shortcut to find the equations if these are your roots. So this is like two separate problems. You'll do it with the root 5 plus 2i and 5 minus 2i. And then in the next problem, you'll do 2 plus 3i and 2 minus 3i. So pause here and then unpause when you're ready to see me work this out. So, and for these, I'm going to show you how to type it in on Google instead of typing it in the calculator in case you don't have a TI-84. So for the 5 plus or minus 2i, my first term is going to be x squared. Then minus 2x times a, so 2x times 5 is a. And then plus 5 plus 2i and 5 minus 2i. And so like I said, I'll show you how to type that into Google this time. So this is just a regular search, and so I would type the equal sign first, and then I would type 5 plus 2i and 5 minus 2i, and just press enter, and it'll give you the answer. So in this case, it would be 29. So I would come back over here, and all of that just equals 29. So my equation is going to be x squared minus 2x times 5 is 10x plus 29. And it would be y equals all of that. So then for my second one, the 2 plus or minus 3i, I would have x squared minus 2x times a, which is 2, plus 2 plus 3i times 2 minus 3i. And I would start simplifying, so I would have x squared minus 2x times 2 is minus 4x and then I'm going to multiply my two imaginary roots together, so 2 plus 3i times 2 minus 3i. So I'm just going to come here and type that in. So, okay, apparently there's a smiley face if you just type equals and start looking there. But anyway, 2 plus 3i and 2 minus 3i. And that's going to give you 13. So I'll come back here and just put plus 13. So that is pretty much it for writing equations from imaginaries. It's definitely easier if you just have plus or minus a number with your I, but if you do have that a value in the front, then you can use this shortcut to find the equations. And then sometimes you may be given something like this, and then you have another real solution of, say, x equals 1. So if you had that too, so just say you have x equals 1 as another solution, you would basically go ahead and find the equation for the imaginaries, and then you would just multiply it by x minus 1, because that's the factor that gives you x equals positive 1. I'm not going to go through the process for all of that, but you may see something like that in the homework. Just make sure you find the equation for the imaginaries first, and then you can multiply it by whatever real factor you're given. And that is all.